Hey there. Getting ready for your GCSE Engineering exam, you probably know that designing pretty much anything is all about making some really tough choices. In this explainer, we're going to dive into section 1.3 and break down all those key factors that engineers are constantly juggling.
So yeah, if you're in revision mode, you are in exactly the right place. We're going to cover the essentials. We're talking energy, product lifespans, and all those outside pressures to get you totally prepped for your exam. So let's start with the first and maybe biggest decision an engineer has to make. How are we going to power this thing?
You know, deciding how to power a product, it's kind of like choosing the engine for a car. It completely dictates everything that comes after: the product's shape, how much it costs, and of course, its impact on the planet.
When it comes to energy sources, they really fall into two main camps. On one side, you have the non-renewables, right? Things like coal and oil. Once you burn them, that's it, they're gone for good. But on the other side, you've got renewables, the ones that nature keeps topping up so they're sustainable for the long haul.
So, what's the big deal with fossil fuels then? Why do we still use them so much? Well, it's pretty simple. They're reliable. All the infrastructure, the power plants, it's all there, ready to go whenever we need it. But, and it's a huge but, there's a massive trade-off. Burning them pumps out byproducts that cause pollution, acid rain, and are a major player in global warming.
Now, let's talk about nuclear power, which is one of the biggest trade-offs in all of engineering. The upside is just incredible. You take a tiny bit of material and create a massive amount of energy with very low pollution. But the downside is just as big. The waste it creates is dangerously radioactive for thousands of years, and the cost to safely shut down old plants is just astronomical.
And on the renewable side of things, you've got wind power. The advantage here is super simple. Once you've built the turbine, the fuel, the wind, is totally free. That makes the running costs really, really low. The obvious problem, though, it's completely at the mercy of the weather. No wind means no power. And then you've got the human side of things, like some people really don't like the noise or how they look on the landscape.
Okay, but a product's impact isn't just about its power source. Not at all. It's also about how long it's actually designed to last. Engineers have to think about the product's entire life story, right from the factory all the way to its very last day of use. This brings us to a super important term for your exam: the engineered lifespan. This is the exact amount of time a product is designed to work properly. Now, sometimes this includes something called planned obsolescence. Like when your smartphone stops getting those crucial software updates after a few years. That's done on purpose, either for business reasons or sometimes even for safety.
So how do we make things last longer? Well, it really boils down to two different ways of thinking about maintenance. The first is reactive. That's kind of the firefighting method. You wait for something to break, and then you rush in to fix it. The other is proactive, which is all about fire prevention. You do scheduled checks and services to stop things from failing in the first place.
So what does proactive maintenance actually look like? Well, it can be really simple stuff, like just lubricating moving parts. Or it could be replacing components that you know are going to wear out eventually. And it can even get really high-tech, like using complex data analysis to predict almost the exact moment a part is going to fail.
And finally, let's look at the wild cards. These are the external pressures that are often completely outside of an engineer's control. These things can totally change the direction of a project, sometimes really dramatically and with almost no warning at all.
I mean, just take material availability. An engineer could spend ages picking the absolute perfect material for a design, but what happens if their supplier suddenly goes out of business, or the price of the material just skyrockets, or new trade rules mean they can't even import it anymore? All of a sudden, the entire design has to change just to survive.
And it's not just about supply chains. Sometimes the biggest external pressure is, well, us, the customer. What we want, maybe it's a specific color or a certain finish or just how the product feels in our hands, can be just as critical to the design success as any of the material's physical properties.
All right, you've just absorbed a whole lot of information, so now it's time to put that new knowledge to the test. We're going to do a few quick-fire questions, just the kind of thing you might see on your exam. You ready?
First question up. Explain how the use of fossil fuels can affect the environment. Just take a second and think about those byproducts we talked about earlier.
Okay, have you got an answer? It's all about the byproducts from burning them. These cause some serious damage, like pollution, smog, acid rain, and of course, releasing gases that contribute to global warming. If you got any of those, you are absolutely on the right track.
Okay, next one for you. Describe the basic process of how electricity is generated using nuclear power. Think about that chain reaction, from heat all the way to electricity.
So, the key thing here is that radioactive materials, through a process called fission, produce a huge amount of heat. That heat is used to create steam. That steam drives massive turbines, and those turbines spin a generator to make electricity. Simple as that, really.
And for our last question, nice and simple. Give one advantage and one disadvantage of using wind to generate electricity.
And here we go. A great advantage is the really low running costs once the turbines are actually built. A major disadvantage is that it's totally dependent on the weather. If the wind isn't blowing, you're not making any power. Saying it has a high initial investment cost is a perfectly good answer too.
Fantastic work. Okay, now let's boil all of that down to the absolute key takeaways for your exam. If you're going to remember anything, make sure it's this stuff.
So let's recap quick fire style. 1. Fossil fuels are reliable, but they pollute. 2. Renewables like wind are sustainable, but they can be unreliable. 3. Every single product has an engineered lifespan, and doing proactive maintenance is the best way to extend it. And 4. External pressures, from supply chains to what customers want, can completely change a design.
And I'll leave you with one final thought. Go and look at a product you use every single day. Your phone, your trainers, even your kettle. Which of these factors we've talked about, energy, lifespan, or those external pressures, do you think was the biggest headache for the engineers who designed it? It's a really cool way to see these ideas playing out in the world all around you. Good luck with your revision.